Okay. Hello, everyone. We are at Brainfood Talk, another session from Square on YouTube, and we are live. Today, we are going to speak to talk about Roslyn, and I am your host today. I would like to switch the slides now to start our talk. So today we will talk about Roslyn. It's the .NET compiler platform SDK. That's the main topic, and I am Shahab, and uh, I'm focusing on software architecture and transformation. I'm a .NET C# enthusiast, and I'm working as a lead software engineer at Square. Today's session will include a coding session. So I will implement some features about the Roslyn that we are going to talk about and dig into those topics. If you are interested, you could clone this repository, code online with me, or just try it yourself later on. This is the URL, so feel free to copy this URL or scan the QR code and have it on your machine. Okay. Today's agenda would be, we're talking about what is Roslyn, a brief introduction about that, and then we have a coding part. At the end, we will have a QA session, and I will answer your questions if I know the answers. Let's start. Compilers, they were a black box for a long time for developers, and how we were working with them was like we were providing them some source code, and we expected some files at the end to be as an output of these compilers. For instance, we were providing some C# files or VB.NET files as source codes, and then we, depending on the type of the application, it would provide us with an assembly as an exe file or DLL file. And obviously, this would be the output if there were no errors provided by the compiler or reported by the diagnostics of the compiler. And as we know, the compiler was consists of several phases. Each of these are acting as a separate component. And we have the parser, which is responsible for tokenizing and parsing the source text into a syntax tree that is following the grammar of your language. For in this case, C# in our example, or any other language. That's the parser's responsibility. Then we had the declaration phase. The focus of this phase is to analyze the source code, import metadata, and form named symbols and these kind of object model for us. The next would be the binder, which is matching the identifiers to code symbols. And the next one, or the last one, is the emitter, which in .NET environment, it is the IL emitter, which is the intermediary language, and it will emit the exe file, and all of those things is built up upon all the features before on the compiler. Uh, this was a black box. What if this wasn't a black box and the compiler provides us with some APIs that we could communicate with the compiler during the compilation phase? So in Roslyn, which is the .NET compiler platform SDK for C# and VB.NET, it exposes some APIs for us for each phase in the compiler pipeline. And these are forming with each other the compiler API, which is one of the APIs exposed by Roslyn. And we have syntax tree APIs, which is providing a syntax tree, and then we have a symbol API. It provides a hierarchical a hierarchical symbol table. And then we have the binding phase, which exposes the results of the semantic analysis, and the emit phase, which is producing the IL bytecode. So for each phase, we have a representation. These are extension points that we could communicate with the compiler at compilation time. Either we are getting some information from them, or we are adding some information to this compilation phase. And all of these components are combined together as a single end-to-end whole. There are features, for example, in your IDEs, for example, Visual Studio or Visual Studio Code or JetBrains Rider. They are using the same APIs that are provided as an underlying API in here. For example, when you have color codes for different tokens in your in your source text, it uses the colorizer is using the syntax tree. Whenever you want to extract a method, it uses the binding APIs and the flow analysis APIs. So these are built on top of the same APIs exposed. And today we want to see whether we as developers could also implement something on top of that and extend these capabilities based on the requirements of our team. There is another API that today we want to talk about, and that's also the diagnostic API. It goes hands in hand with the compiler API, and it exposes the diagnostic reports of the compiler during the compilation unit. And its focus is on reporting issues, error, warnings, code suggestions, and this is the main focus of diagnostic API, and it provides like feedback about code quality, correctness of the code, stand adhering to the standards, or and things like that. So these two APIs work hands in hand. The compiler API, which is those four APIs together, and the diagnostic API, and we are going to use these APIs. So far, we talked about APIs, and alongside with the compiler API in Roslyn and the diagnostic API, we also have a scripting API and workspaces API. And the scripting API is built on top of the compiler API, provides us and can be used and provides us with a run code snippets and also an execution context that we could accumulate code on top of that. The interactive C# REPL is actually built by using the scripting API. The workspaces API is useful whenever you want to uh, do code analysis and refactoring solution wise. So you have multiple projects, they have dependencies to each other, and you want to refactor those kind of solution wide refactoring, and you want to have solution wide analysis. It provides you with an object model that consists all the data that you require for doing those kind of analysis and these things. And in today's session, we want to use the same APIs to enhance the productivity in our team and empower the tooling to enforce coding standards and providing guidance for our team members. And we want to do that by implementing a semantic analyzer that analyzes the source code that we have, and it provides a report to the diagnostic API. So if something is wrong, it will report to that diagnostic API, and it will be shown during the compilation. And if everything is fine, then it will just not report anything, and the compilation would continue. Uh, this is helping us to unify the build process on our development machine and the CI/CD pipeline, and making sure that all the standards that we want to be adhering to uh, is all the team members are sticking to those standards, and they are not we are not missing anything. Before getting to what is actually the problem that today we want to solve, I would like to introduce you with some side tools that we will use today. One of the tools is Sharp Lab. This is like a playground for C Sharp and C Sharp and Visual Basic and other .NET languages. And here I have a valid C sharp code, and we could see that it provides us with different kind of output. It provides us with an explanation like what is the default, links to the documentation. It also provides us with the IL code of this code that we have written here. And the thing that is important for me today is the syntax tree in here to look into that. In every syntax tree, we have a root node, which is the compilation unit. We have the compilation unit as a root of this tree. And for each piece of code that we have here, there is a representation in the syntax tree. For example, here I have a class of customer repository, and here you would see that I have a node here named class declaration. which represents that code. And if I select that one, you will see on the left side it is highlighted. And if I go down the street, there's a method declaration, which is the method defined method that we have in here, and return type, the body, and all of those things. One of the important things to remember, because we need that when we get into the coding part, uh, is the operation that we see in this trade. The operation is the actual thing that is happening for this node, and the nodes have like C# class representation for themselves. So this node is of type through a statement, and the C# representation would be through a statement syntax that we will use for. Why we need this tree is we decided in our team that we are going to use some functional programming patterns like the maybe pattern and result pattern. If you're not familiar with that, I would suggest to watch a video from my colleagues. They're talking about the functional programming in C Sharp. You could find it on our YouTube channel in more detail. They will describe them in more detail. But what we decided in our team is that whenever we are using these patterns, we don't want to throw business-related exceptions. Of course, when, for example, here in this line, I'm going to try to get a value from database or a network or somewhere, some exceptions might happen. Those exceptions will be handled gracefully as a global exception handler for us. But having through customer business related exceptions, we want to avoid that. And instead of that, we want to stick to the patterns of the functional program. And this happened in our team that sometimes the newcomers are not familiar with this approach that we are using, or by mistake we just put a through a statement, and also in the code reviews we missed that, and this piece of code that is not based on our standards in our team gets deployed to the production. The other tool is Roslyn Quoter. I will get to this later when we want to actually use that. But this is a tool that helps us to generate a syntax tree by using C# classes. We will see that in action later on. And we need that because first want to analyze this piece of code. So everywhere that we have a throw statement, we want to replace that with a suggestion from our. We want to first tell the developer that you should not use through a statement in here. So this would be an error or a warning, depends on like how we set the severity of this standard. And then we want to have a suggestion for that. So to achieve that, we are going to create a semantic analyzer. The role of this analyzer is to process our source code, find all the throw statements, and check whether they are within a method with a return type of maybe or not. And then providing a feedback to the diagnostic API for reporting an error. The next things we would want to provide a code fixer. The code fixers are providing the developer with an alternative way of doing what is reported as a warning or as an error, right? So what we want to suggest the developer is instead of throw a statement, do something else. And that would be something that we want our code fixer to suggest and automatically help the developer to implement that. And I already described the problem, so let's go into our source code. Here, let me go to presentation mode and uh, do that. As you saw, we have a customer repository. You already, okay, and let me close some of Okay, so we have this method in here, and we are throwing a not found exception here. But what we want to actually do is we want to return maybe not none to represent the non-existence of a customer when an invalid customer ID is replacing. And when I'm doing that, you see that I have like three dots in here. It is like suggesting me that you could convert this to a tertiary operator, which I'll do. It will be like this. So we want to implement the same thing. So first of all, we want to have some red squiggles in here to mention that this is not recommended. We don't want to do that. And then a code suggestion with this light bulb. If you clone the repository, you will see a source folder. There's this API which provides like API REST endpoints, and then we have this code fix analyzers. It is already referenced in the other project as an analyzer. This is important because if we want to, the compiler knows that we have an analyzer in here. And in that one, we have a maybe semantic analyzer and a code fixer. First, let's get into this analyzer. So every analyzer starts with inheriting from the diagnostic analyzer, and we need to distinguish between different analyzers. So we need to provide the diagnostic ID as well in here. The standard is like to having some characters that represents your project, and then having some auto incrementing numbers depends on the uh, number of your analyzers in that project. And there are some other stuff like the title, the message, description, and everything. The important thing is the this diagnostic descriptor, which is like a rule. This is something that describes the whole diagnostic by itself. And in that one, also the most important one is this severity in here, which is like an enumeration. It could be errors, warning, or hidden info. In this case, I want to go with error. And when we are inheriting from the diagnostic analyzer class, then we need to implement the initialize method or override the initialize method. And in that one, every action that we are registering would be processed for us during the compilation phase. So if you remember, I said that in here we have like the operation node in every syntax node. We have this operation which represents an operation that is an action that we are doing in our that is happening in our compilation phase. And this here we are interested in through statements. If I go back again for the through a statement, you will see the operation here is through. So that's what I'm interested in. Okay, so uh, let's get it started. First, I want to do some checks in here. I want to check, for example, the context that operation uh, is of I throw operation. If it is not, then I want to just return and do nothing because that's the thing that I'm interested. Or if the context that the operation that syntax node is of type statement throw statement syntax. I said by adding a syntax to the end of every blue node in here, you will get the C# class. So it's through a statement, it would be through a statement syntax. So if it's not any of those things I would like to return in here, then what I want to do is if we take a look into the syntax tree, here we have the through a statement. This through a statement is inside an if statement, and that one is inside a method declaration uh, node. And I want to traverse this tree up to that node and check for the return value of this method. If this return value is of type maybe, then this is the scenario that we want to act on that and provide some reports to the API. If it is not, then we are just fine, right? So let's implement that. So I'm saying var return type node or syntax would be, let's say, get containing method syntax. And here I am passing the I am passing the syntax node, this through a statement syntax node that we were interested in. And this is returning a declaration method, declaration method, declaration method syntax. something odd with the IDE. Let's do that like this and create method and sorry, method declaration syntax was the type that I was looking for. And here we say just syntax node going in here. So we want to traverse the tree until we are getting to a parent of this node is the method declaration syntax. So if my node that I'm checking, its parent is of type method declaration syntax, I'm just giving it a name, and I'm just returning that parent. If it is not, I want to check the other one. So it's like a recursive way of implementing this approach to traverse up to the a specific node that I'm looking for. And we know that the parents are not null because in this structure, it is a nested structure and all of them having a parent. So I think I have a typo in here. Let's do that method syntax. Okay, so I have the syntax node for this method, uh, but that's not sufficient. We have the syntax. We want to make sure we need to check another thing. As you know, we have namespaces and packages, and it could happen that coincidentally we have another maybe type inside another namespace, which is not our target namespace. So we need to semantically also analyze this maybe type that we are getting to make sure that this is exactly the type that we are looking for, and it's not just coincidentally the same name. So factor. So I need the semantic containing method symbol or semantic of that. And here the context, this operation analyzes context provides us with semantic context operation, that's semantic model. And from that, we could get a symbol as the symbol that represents the meaning of this syntax node. So in this case, I'm passing the return type. It's not the return type syntax, it's the containing method syntax. Now I have the symbol or the semantic of the method declaration. Now I could extract the return type from that symbol, and this would be the containing method symbol dot return type. And I'm just putting here like a not null operator. Then I would have so now we reach this method type. We need to compare this one now with the actual maybe type in our code. And if I go there in this project that we have, there is this one, and we have a maybe type. So we want to make sure that this is exactly this generic maybe type that is reside in this namespace for us. And we want to compare it with this one. So back to our analyzer here, we are going to get the meaning of that maybe type symbol. And again, the context provides us with the compilation unit that all this is running on. And then we have the get type metadata by name. And we know the name is, we already saw that, it is this namespace. Dot maybe, and this is how you represent generics in here. So we have those things, and now we need to compare them. Let's do that if return type symbol dot equals the maybe type symbol that we have found in here, and we need to provide a comparer. In this case, I'm just providing the default comparer. If they are not the same thing, then we just want to return because it's just coincidentally they have the same name, but from the meaning, from the semantic, from the symbol wise, they are not the same thing. There's a problem in here. The problem is that here in my repository, this is type maybe of customer, right? But when I wanted like to get this maybe type, this is the maybe of T. So they are definitely not the same thing. So I need to make sure that this maybe of customer, it has kind of like an original definition, so to say, and we want to compare that original definition of this to the actual type that we are checking. So in here, if I compare this one, it will fail. But if I compare the original definition of that, then hopefully it will pass. We will have we are having some unit tests, and we will see that in action. So after that, then we are sure that this is the same type, and we want to report something to the analyzer. So I'm creating a diagnostic, and here I could say diagnostic, create, and then I'm passing the rule that we have defined. Is uh, this rule is what we have defined in. It has this severity, it has the title, it has the diagnostic ID, and all of those things. And we want to say that we should also say where to show this diagnostic. You see that I have red squiggles in here, right? And if I go to my repository in here, I want to say that also show that in here. And that is where exactly the throw statement is, the syntax node for that is. So I could use that context, that operation, that syntax node, and get the location of that throw statement and report exactly. And if I do the context dot report diagnostic, I'm diagnostic, reporting this diagnostic that we have created. So this is all the code that we need to write to analyze this piece of code. As I said, we have some unit tests. Hopefully they will pass. Check them. We have these semantic analyzer tests, and let me first build the. Let's go to the tests. Unit tests. Oh, we have some failures. Uh, so let me build the API. Uh, okay, I have no idea why this is failing now. What would be live coding without failing, right? Just give me a second, and did I miss something in here? Maybe if context that operation that semantic model is null also return something. This should not be an issue. Let me just double check again the code in here. Okay, let me just, I have a backup thing. Let me just simply provide the code that I have in here. But it should be basically the same thing. Okay, yeah. So we have the red squiggles in here, and you see here it's reporting the ID and saying use maybe that not instead of throw exception. So this is the first phase, and you see the light bulb is already like suggesting these things, but since we have not implemented the code fixer, uh, it is not working. Let's go, and we said we want to replace this part with return maybe dot none, and this is something that we want to implement. There was another tool that I mentioned, the Roslyn quoter. If I want to generate this code, I could use that one and say get Roslyn API calls. I don't know if it is should I zoom or not? Uh, Here it generates a C# code that this code itself is generating a syntax tree for us. And you will see that it also starts with compilation unit. But I'm not interested in the whole syntax tree in here. I'm just interested in the return statement for that syntax tree. Because if this code has a syntax tree that represents that, if I just switch the throw statement in this tree with something that I want, which would be this return statement, like return maybe dot none, you will see at the same position, now it is changing to a return statement. Then I should be fine, right? When I'm so we said that these APIs are providing a way to communicate and extend as an extension point to communicate with the compiler APIs. So if I could read the syntax tree, then I should be also able to manipulate the syntax tree, and then it should generate a new source code for us. So by copying this piece, let's go to our code fixer now. By the way, I'm just running the tests again just to make sure. Run unit tests. Yeah, they are now passing. Probably just some minor mistakes were there. Okay, code fixer. Again, this is also inheriting from some base classes, obviously code fix provider or something similar. The important things in here is that we need to connect this code fixer to a diagnostic ID that we had. So this is the same diagnostic ID as the diagnostic that we are providing. So now the compiler knows that if this has been reported as an error or warning, then I need to suggest whatever this code fix provider is providing for me. And then you also need to override the register code fixes async method in here. And here I'm also checking whether this is a throw statement syntax analyzes, like the node that was diagnosed is of type throw statement syntax, and then we are registering a code fix action for it. So let's implement that one. We said that we want to replace the node, this through syntax node, with a return statement node. So the first step would be to create the return statement that we are interested in, and I'm going to use the provided code. All of these methods and classes are in the syntax factory. Syntax factory. And just for the ease, I'm gonna import the static members, so all of them are here. There is one specific type of nodes in the syntax trees, which are called trivias, and they are these. If I can find one of them, yeah, these are trivias. They are not playing any role in the semantic of the code, but they are helping with the layout and the format. And if we want to suggest a code that replaces another code, it is better that we respect those trivias and save them so we are not ruining the formatting of the application that the developer is working on. So I'm gonna use that, and I'm going to say with a leading trivia, and I'm using this through statement node dot get leading trivia, and also the trailing trivias for that one. So that with trailing trivia and the throw statement syntax node dot get trailing trivia, and then we should be fine. So this would be yeah, this is our return statement. And we want to now replace this return statement in our syntax tree with for the throw statement. In Roslyn, everything is immutable. So if I am replacing a node in a tree, it means that I'm creating a new tree. It's not like an in-place replacement. I need a root here. It is the current root, like that's my name it the current root, and this is coming from my document. The document get a syntax root async. This is a non-blocking operation, so I need to pass a cancellation token, and I need to await this operation. So I'm not blocking the main thread. And then I am gonna get a new root by manipulating this current one with replace node. And I'm replacing the throw node with this return statement node. Okay, so we know this is not null, and let's go there. And then we need to create a new document that this syntax tree or this source code is in that. So it would be again like return document dot with root or syntax root, and this would be our new root. So this will be creating a new document of the old document, and we replace the old one inside the project that we have. Let's give it a try with our test in the code fixer. Let's see if it's green. It's not. So again, probably I missed something. Yeah, this is like the thing that I was talking about. We are not respecting the trivias in here. So this is like reducted from our source code, but we are not doing that. So probably I have put this with leading trivias and things in a wrong place. Let's just move them one down and give it another try. Yeah, now it's working. So if we go in here, I will probably need to build a solution, but let's see. If I'll go to this action, I say replace, yeah, because this is a reference project, so it needs to be built first. And let's go in here, Alt Enter, replace, and you see now it is replaced the code and the error is gone. So, and these features that we have implemented in just with some lines of code, these are compiler features. This is not bound to my IDE, which is a rider IDE. So to prove that, I could like go to Visual Studio Code, for example. And if I go to this customer repository, maybe I should zoom a little bit. You will see I have the same error in here, and I have the light bulb in here. And if I click that, it will also replace that. So this is something that is not bound to any ID. The more important thing is that it's also like if I use the command line to build my project, that's meant to build in this case. Just zooming as well here, just for the presentation. Let's do that again. .NET build. You will see I have an error of type CGAR01, and it also says use maybe instead of that in your in this file at this location. And if I solve that one, I also replace this, and we going .NET build. Hopefully that will be gone, and the build is successful. This is the important aspect: is that it is something that could be also integrated with your pipeline tool. So I created like GitHub Actions. Let's try to push all our changes to our GitHub repository with trying to implement a semantic analyzer and the code fixer. Pushing the changes. And and let's go to our repository in here. If we go to the actions, we will see we have this one that we are having in here. Let's see, will this also disappoint us today by not failing, or will it fail? Okay, it failed, and it says that you have this error in here in these two lines. And if we go and fix those errors, hopefully on the next push, it should be a successful run. And I have just one place, Control K, commit and fixed, uh, used maybe that none. Let's see that again in action. The actions. Okay, build succeeded. The tests are green. Yeah, the whole pipeline is now green. So now there's all of those environments that we are developing are unified in the way that we build and adhering to the standards and guidelines that we are providing within our team. Okay, let's get back to our slides here. We had this whole picture and we used some of these APIs to implement the features that we had. Let's clear some noises in here and see what APIs we actually used. For the semantic analyzer, we use the syntax tree API and symbol API and the diagnostic API uh, to report back to the compiler with the diagnostic that we have detected. And the code for the code fixer, we have used the syntax tree API and we manipulated that one. And these were the features that we have used from this. Okay, cool. Now I think we will have a QA session. Please put your questions in the chat in the YouTube channel. In the meantime, I would like to tell you about the events that our company is organizing a yearly conference in Vienna. It will be this year on May 16th, Code Crafts, and you could find more information about that on code-crafts.com. Uh, we have speakers from around the globe about different topics that affect the development cycle of the company, from organizations to architecture to code and everything. And we also organize some workshops regarding those topics. If you are interested, you could also register for the workshops. They will be on May 15th. And as I said, get your ticket if you have not already bought your tickets. You will find all the necessary informations on code-crafts.com. We also host a meetup on 18th of April. It is hosted by the speaker is Philip, the co-founder of Glasscube, and he will be talked about developing cloud native apps on Kubernetes, including Helm and also Glasscube. Join us. It will be hosted on our company, so we would be glad to see you there. Please follow us on YouTube, LinkedIn, and on Instagram. And if you want to be in touch with me, I'm Shahab, and you could follow me or connect me on LinkedIn. Okay, now we have time for the questions. Okay, there's a question from Paul. One question starting with what size of the problem would you consider a team solution, a specific analyzer or fixer? Uh, Let me starting with what size of the problem would you consider a team solution specific analyzer? I'm not sure if I correctly understood your question. Do you talk about like the analyzers that are affecting the whole solution, like when you want to use the workspace APIs, or do you ask a question like generally, like when should we use the analyzer to implement an analyzer or a code fixer? If it's the latter one, then for any size of problem, you could implement that because it could unify the development pipeline for you on your machine and in your CI/CD pipeline. And it also helps with the newcomers to your team when they are implementing some pattern. You already have some tools that will help them. So it could be even like a syntax tree analyzer, like the naming conventions, for example. You could have like if a file is inside this type of projects, it should end up with repository or service, or you could have like semantic analyzers. For the solution wise, uh, con- yes, considering the amount of work it takes to implement a non-trivial analyzer or fixer. Uh, yeah, it takes some amount of time. So I would suggest like that if you really cannot implement the things using linters or those kind of tools that already like providing some guidelines to some extent, then when it's getting more complex, you should use this approach. And uh, the other things, is there a way to minimize the effort? Paul, I don't know if I have answered your questions. Please let me know. Martin is asking, is there a way to minimize the effort spent on setup? Uh, Do you mean like the project setup, Martin? If that is the case, yes, all the IDEs, well known, are already providing a template, so you don't really need to do any setup for the project. And I actually use those things if that's the question. And then you need to focus on your implementing your analyzer. So it would be like your case. Analyzing the syntax tree or the semantic and to understand what you need to implement, and then you just implement. And everything is there. You could also, for packaging them as a NuGet package, it's like the standard way that you use any .NET application to pack any of those applications. You could just use the normal way to package this, and they will be marked as analyzer. So if you add this package in your project, it will be detected automatically. I don't know if I have answered your question or not. Thomas has this question: where would you see the benefits compared to a linter? As I said, when it comes to more complex scenarios, or when you, for example, need to do some solution analysis as well, you could use this approach instead of linter. I am not very proficient or expertise with like how far linters could help you. I'm not sure if this example that we had, like the linters could actually analyze the semantic of the code, because you could also have like dependencies between documents and documents inside of one project, not generally in between those things. So I'm not sure if linters could tackle those things or not. I hope Thomas have also answered your question. Okay, if there are any other questions. Just one addition, I usually get this question that whether there are similar tools in other languages or communities or not. As far as I know, any modern language that does some kind of AOT or weaving, they will have some sort of this mechanism. For example, I know that in Java there is like this Java compiler API, or in Rust and Scala, I know similar things exist that they could also help to work with the AST and this stuff. But I'm not sure how mature they are or how they are working. Is it the same way that the Roslyn is working, or is it different? Because I'm not that deep into those communities and languages. Okay, it seems that we do not have any more questions. Thanks, Peter. Then I wish you all a nice afternoon and a brilliant weekend ahead. Have a nice day. Bye.